Hello everyone, welcome back to Code with Raj. So today we would be solving next question from our top interview 150 series. The next question is remove duplicates from from sorted array part 2. So this is a similar kind of problem which we solved earlier. But so first let us read the problem statement. Given an integer array nums sorted in non-decreasing order, remove some of the duplicates in place such that each unique elements appear at most twice. So in the last question, we just need to do it for once, but here they're asking for twice. The relative order of the element should be kept the same. Okay, since it is impossible to change the length of array, okay, again the same thing, and again the same custom rules. So let me explain the problem once. Okay, so let us work with the example number 2 only. So we are given a nums 0, 0, 1, 1, 1, 1, 2, 3, 3, and in output we need to return the number of unique elements that are appearing at most twice. So 1, 2, 3, 4. So total, like uh, four numbers are there which are unique, and among those four, 2 times is 2 0, 2 times is 1, 2 times is 3, and 1 time is 2. So total number of elements would be 7. The output array should look like 0, 0, 1, 1, 2, 3, 3, and we need to return this number 7. So basically we do not care, and we should do it in place in nums vector only, and we are not caring about what is present after here, because the custom judge will only check till this much. So like, what is the approach to this question? So if we think in simple terms, let's again take the same example only. So simply what we could do is we could store count of every number in a map, again same, making a hash map again. So in a map we could store the count of each elements by iterating over all the elements, like for int I is to nums, we could just do mp of I plus plus, and at last we could iterate over the map and store the number twice only. So if we found 1 and its frequency is greater than or equal to 2, we would push back 2 times only. If it is less than 2, means it is 1, so we'll push back once only, like 0, 0, 1, 1, and 2 will be only present once in the map. So it would be like this: 0 is coming 2 times, 1 is coming 4 times, 2 is coming 1 time, and 3 is twice. So we found that 0 is coming twice, so we put two zeros, and we found that 1 is coming 4, but since the problem is saying we need to only output at most 2, so we'll put 2, and 2 is coming once, so putting 2 here, and 3 twice. So this is a very naive approach through which you can solve this question, but this would take some extra space here for creating the map and creating a temporary vector to return this also. So like big O of n is a time complexity because we are iterating only for one pass, and big O of n is a space complexity. So this extra space we need to optimize, because in the question it is written that you need to solve this in big O of one space only. That is the most optimized solution. So again, since we are working with two pointers in the previous part, we will again try to use two pointers here. Uh, okay. So like, how can we do this problem? One thing you can notice is, like, let us write the test case again, that we are only caring about the first k elements that are appearing almost at most twice. So like, if and we need to also utilize the property that the given array is sorted. If we were to go with our previous approach, it was we are not utilizing the property that this array was sorted. So now what we could do is, since we want that uh, element should appear at most twice, we could like start with two elements, like checking two elements. What we could do is, we could start from here, because we know that any elements that are present before this are smaller than this and are different, or if they are same, they are appearing at most twice only, because we are starting from the second index only, 0, 1, and second index. So now what we could do is, we could check if this index is not equal to this index, then we would place it here. If not, if it is equal to 0, then we will not place it here and we would move to next index. So what I'm saying is, for example, if this would have been 0, 0, 0 and 1, 1, 1, and our pointer was here, and we found that this element is equal to this element. So instead, what we would do is, uh, we would ignore it and move it here, and our other pointer will remain here only. And then we found that if this is not equal, then we will place 1 here. So we will keep on doing this. So if let me do dry run on this case only, 0 0 1 1 1 2 3 3. So we are iterating from second position. So here, if this is different, we will move on, different, move on. And next, when we found that this element is equal to the like index which is 1 minus the previous index, basically, like if this is k, this is k minus 2. So if this is equal to k minus 2, we would skip this element and this pointer would remain here only, and our next will move on here 1. Again we found same, again we will move, then we found a unique element, then we would put it here 2, and at this pointer will shift here. So now the array would look like 0 0 1 1 2 1 2 3 3. Now again we will move on here and we will find that this element is equal to the k minus 2th element. So again we will put we will ignore this and move on here, and we found that we got a different element, so we will put it here 2. So our next array would look like 0 0 1 1 2, yeah, and similarly for 3. So at last we would get 3 3 because I guess it is coming for twice only. So this will be our output, and at last I think these like 2 3 3 will remain, but we don't care about these elements, we only want to output these elements only. So like once I write the code, I think it would be more clear. So let us jump on to the code editor only and write the code for this. Okay, so quit. So first of all, let us take int n is equals to nums dot size, which will represent the size of the array, and we will have a pointer k, which will be initially 2, because we know that if only two elements are present in the array, we need to just return the array, because two elements may be same, may be different, it doesn't matter. Our solution will get passed on that. So let me add a edge case. If nums dot size is less than or equal to 2, we would just return nums dot size, because we know that it is already sorted and like appropriate according to the conditions given in the question. Now here we will start from the second index of the array, int I is equals to 2, I less than and I plus plus, and we know if nums of I is not equal to nums of k, that means this is the case where we need to put different element. So we will do nums of I, sorry, nums of k equals to nums of I, because k is the pointer that is keeping track of the elements according to the question. So we will do nums of k equal to nums of I, and after that k plus plus, because once the particular k position is fixed, after that we need to move on to the next position for the next correct element, and at last we would just return k. And I think this solution would work fine. Let us try and run it once. Okay, so we got a wrong answer somewhere. Mm, yeah, so the problem in this, we have a bug here, small bug. So basically what we are doing is we are comparing nums of I with, we need to compare nums of I with the k minus 2th element, because we are checking twice the position back. So k minus 2 should be here, because k is initialized to be 2 and we need to check from the starting of the array. So we need to put k minus 2 here. Yeah, so it is working fine. And for debugging purposes, let's once print the array also. For int I is to nums. So you can see here our standard output 1 1 2 2 3 3. So what I was trying to say is, yeah, when we were copying the element, this last element we didn't care about, so it remained as it is. Let's see in the test case 2 also. Yeah, so see 0 0 1 1 2 as it appear once, and since all these were copied here, so these 3 3 3 will remain as it is, but we don't care about them, because the custom judge will only check for the first k elements of the nums array. So let us go and submit the solution. And our solution got accepted. Don't care about this, because this changes as if you submit multiple times. This is the most optimized approach which we could think of. So the time complexity is big of n, and the space complexity is big of 1. So this is the most optimized solution for this problem. I hope you liked the solution, and please make sure to like the video, and please also press the subscribe button. And I would like to hear your feedback in the comment section, that what else you want me to do in my videos, and what else you want to want me to teach. And the codes link would be available in the description soon. Thank you so much for watching. Bye.